Hi, this is Mrs. Gallagher, and today we're going to discuss zero and negative exponents. So whenever we have a zero exponent, our key concept is for any non-zero number a, so if we have a to the 0th power, that's always going to be equal to 1. So whenever we have an exponent with 0, it's always going to be equal to 1. So let's take some examples. Directions: simplify each expression. 7 to the 0th power. Whenever our exponent is 0, your answer is going to be equal to 1. Number 2, negative 8 to the 0 power. Again, to the 0 power, your answer is going to be equal to 1. Let's look at number 3. We have 3 times m to the 0 power. Okay, so your exponent goes with the m. It's m to the 0 power, and that's equal to 1. So to rewrite this, we have 3, because we're going to bring that number with us in front, and now we're going to times that by m to the 0 power, which equals 1. Therefore, 3 times 1 equals 3. Let's look at number 4, 2x to the 0 power. So our exponent goes with the x to the 0th power. So we're going to say 2 times x to the 0 power equals 1, and 2 times 1 equals 2. So our answer is 2. So now let's look at example 2. It says, using the dividing powers rule and this relation that you defined above, complete the following. It says y to the 4th power divided by y to the 4th power. And if you recall, when we are dividing our exponents, we're going to subtract them. So let's rewrite this. We're going to say y, and we're going to say 4 minus 4, because we are subtracting our exponents. And therefore, 4 minus 4 equals 0. So now we have y to the 0th power. And now when anything is to the 0th power, what is that equal to? Well, it's going to be equal to 1. Therefore, y to the 0th power is equal to 1. And that is your answer. So I would like you to do the U try section. You're going to simplify your expressions for letter A, B, C, and D. And then for E and F, you're going to simplify the expressions, then evaluate. Okay, now let's discuss negative exponents. So a key concept for negative exponents. For any non-zero number A, the integer n, we have a to the negative n power. It's going to be equal to 1 over a to the nth power. So what you always want to do is make your negative exponents positive, and we make them positive by making it into the denominator. So let's do an example. If I had 8 to the negative 5th power, we don't want negative exponents. So what we're going to do is we're going to put it underneath 1 to make it positive. We're going to create a fraction and put it under 1. So that's equal to 1 over 8 to the 5th power. So our rule is negative exponents must become positive exponents by writing it as a fraction. So our rule is negative exponents must become positive exponents by writing it as a fraction. Okay, so we always want to make our negative exponents into positive by writing it as a fraction. So it's going to look like this. So when we ever have a negative exponent, you're going to put your base, make your exponent positive, and it's going to be underneath 1. Okay, so it's 1 over your base, and you're creating your exponent to become positive. So now let's do some examples together. Direction state, simplify each expression. And we have number 1, 3 to the negative 2nd power. So you want to make sure you want to make that into a positive exponent. And we do that by placing it underneath 1. So we have 1 over 3 to the 2nd power. Okay, and it's saying to simplify the expression, therefore we're going to expand it. So we have 1 over 3 times 3 is 9. Therefore, our answer is 1/9. Let's look at number 2. You have y to the negative 6th power. Again, you want to place it underneath 1 to make it into a positive. So 1 over y to the 6th power. And that is your answer. You can't simplify it anymore. Let's look at number 3. 10 to the negative 3rd power. Again, you want to place it underneath 1, create a fraction. So 1 over 10 to the 3rd power. We can expand that. 10 times 10 times 10 gives 1,000. So our answer is 1 over 1,000. And that is your answer. Lastly, number 4, x to the negative 3rd power. You want to place it underneath 1 to create a fraction and make your exponent positive. So your answer is 1 over x to the 3rd power. Let's look at 2 more examples involving our dividing exponent rules using negative exponents. So using this relationship that you just defined above and the previous exponent rules, we will complete the following. You have y to the 4th power over y to the 6th power. Okay, so the first step we're going to do is we're going to subtract our exponents because we're dividing. So you're going to say y, and we're going to subtract 4 minus 6. Okay, and that equals y. 4 minus 6 is negative 2. So now we have a negative exponent. And remember, we can't have negative exponents. So our next step is we're going to place y to the negative 2nd power underneath 1. So our final answer is 1 over y to the 2nd power. Okay, let's look at number 2. We have 4 to the 3rd power times 4 to the negative 5th power. They're the same basis. And we're going to identify our operation where we're multiplying here. So when we multiply, the rule is to add your exponents. So we have 4, and we're going to add our exponents, which is 3 plus negative 5. Okay, so 3 plus negative 5 gives us negative 2. So we have 4 to the negative 2 power. So we can't have a negative exponent. Therefore, we're going to create a fraction, and we're going to place 4 to this negative 2nd power underneath 1 to make it positive. So our answer is 1 over 4 to the 2nd power. But we can expand that. So we have 1 over 4 times 4 equals 16. So our final answer is 1 over 16. So now what I'd like you to do is the you try section. Please complete A, B, C, and D, and we will discuss it in class. Thank you.